أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. So we talked about the physical quantities, we talked about the base quantities, and we said that there are 7 base quantities, and based on those 7 quantities all other quantities are derived. So we had the time, we had the mass, we had the length, so these were the base quantities. So today we will talk about, we start from the dimensions of the physical quantities. Dimensions of the physical quantities. So each base quantity is denoted by a bracket, by its symbol, which is enclosed in a bracket. For example, we had the base quantity, which was the length. For the length, we had its symbol is L. So we take the symbol and we just put it in a bracket. So this is the dimension of the length. Similarly, we had the mass. Mass has the M, dimension is the M. So we have the time, so we have the T, so we have the, so these are the 3. So we had the 7 base quantities, and we will try. So what's the importance of these dimensions? So what we do, for example, we have the speed. Speed is the distance or the length that is covered per unit time. So we have the length per time. So the dimensions will be length divided by time. So length divided by time. Or we can also write L T minus 1. So this is the dimension of the speed. Similarly, we have the force. Is the mass multiplied by acceleration. So acceleration, so for the acceleration, so for the mass we have the M, so we have the mass is the dimension, so M is the dimension of the M. For the acceleration, so we know for speed is the length divided by unit time, and the acceleration is the speed per unit time, change in speed per unit time. So for the acceleration we will have the t squared here, right? So we will have -2 here instead of -1. So it will be L minus 2, or we can also write ML. So this is how we write the dimensions of the equations, for example. So now we can see force is a derived quantity, but we wrote this in terms of the 7 basic quantities. So now here the basic quantity we see here, the mass, the length, and the time. So we relate the derived quantities to the base quantities. For example, so we have the 7 base quantities. So as we said that the dimension is written, denoted by its symbol, which is inside the bracket. So we have the mass, so we have the M is for the mass, and then we have the length, then we have the time, and then we have the N is for the mole or the amount of substance, which is also the base physical quantity, and then K is for the Kelvin, which is the temperature, and then we have the candela, which is for the intensity of the light, and then we have the ampere, which is the electric current. So we will see, so whenever we have the derived quantity, we will try to express those derived quantities in terms of the base physical quantities. So other thing that's important is whenever we see an equation, for example, we have an equation here, the force is equal to MA. What's important here, so the left side of the equation and the right side of the equation, they must be dimensionally equal. So on the one side, for example, on the one side of the speed, if we have the length and then the inverse of the time, on the right side we must have the same thing. So the left hand side must be equal to the right hand side. So that's important. For example, just an example. So we have the example. So example is, if we have a string which is so we have a string. If I just disturb this string with my finger, so there will be a wave that will be produced in this string. So the wave, the speed of that wave is given by, I will just write the equation here. So the speed of this wave, so that will travel in this string, is equal to the tension, which is the force, multiplied by the length of this string and divided by the mass. So now we see here, we have an equation. So what do we see here? So we have the velocity here, and we know the velocity. So the velocity has a dimension of a length and the time inverse. We just calculated it up there. So on the left side of this equation, which is the velocity of the wave that's traveling in a string, must be equal to the right side of the of this equation. So on the left side we have the equation for the dimensions of the velocity. So now we will see if the right side is equal to the left side. So first we write the left side of the equation, which is velocity. Is velocity, and we know that the dimensions of the velocity we just saw there is the length and then the time inverse, and then we put it in a bracket. Now, so the left hand side must be equal to the right hand side. So the right hand side must have the final dimensions, which is equal to the velocity. So we will just write the right hand side. So the right hand side, we have the force, and force we saw the dimension is M, L, T. So so the force is mass multiplied by acceleration. So this is -2. So force is multiplied by acceleration, and then we have L, which is the right hand side. So we write L. And then now we see here we have another M. So M is in the denominator. If we just put it here, bring it to the denominator, we will have the M -1. So the M, so this one cancels. So on the right hand side we have the L square. So we see here 2L. Sorry, this is in the square root. So this is in the square root. So this will also be, the whole thing will be under the square root. So that was missing here. So now we have the -2 here. So -2 is from the acceleration here. And now we have the 1/2 is from the square root, which is here. And now this is cancelled. And finally, we have the right hand side equals length, and now we have the time, which is equal to the left hand side. What we see here from the dimensional analysis, we have the right hand side, which was the velocity, and now we have the velocity, which is the length per unit time here. So this is the left hand side, and now we take the right hand side, and now we write the right hand side, the force, the length, and the mass here in terms of the base physical quantities, the basic physical quantities, which is the mass, length, and the time. So this is for the F, the mass, and then the acceleration, and then we do the analysis, and finally what we get is the L, length divided by time, which is equivalent to the left hand side. So every equation, whenever you see an equation, that must be dimensionally correct. So the right hand side must be equal to the left hand side. For example, we have the kinetic energy equals 1 by 2 mv square. So if you do the dimensional analysis, so this is the energy, so this must be equal to the so the right side, the left hand side must be equal to the right hand side. Similarly, we have the work done. So we have the force multiplied by distance. So this must be equal to this one here. So this has the dimensions of the energy, and work has also the dimensions of energy. Now, using these dimensions, we can also find the equations for, we can guess the equations for different quantities. For example, we have the example is the apple in gravity. So we just take this example and then use the knowledge of the dimensions to find the equation for the time. For example, we have an apple, and we just let it go in the influence of the gravity, and then it will hit the ground. So this is the ground. So when we let it go, so there will be a force that will be acting on the apple, which will be gravitational force, which is mg, and this is the height. So this is the height, so which is h. Now what we want to know that how long will this apple take to reach the ground. So we have the t, time, that should be proportional to the height. If the height is very long, so if the height is long, it will take longer. If it's short, it should take shorter, right? It should also depend on the mass, and also should depend on we do not know if it depends or not. We will just try to find out. Also on the gravity. So we have the h. Alpha can be anything. Right now we do not know, but this is the height. It should depend on the height, the time that it will take. So we have the mass. So we write beta. So we do not know alpha, we do not know beta, and right now this is the gamma. And now, as we said that dimensionally, so for example here we have the time, which has the power is 1. So the dimensions of the left hand side, which is the time to the power 1, it must be equal to the right hand side here. So we just write the dimensions. So here is 1. We don't have to write, but okay, we just write for the simplicity. And now here h, which is h is the length, which is the base physical quantity. We write alpha, and now we write m, which is the base physical quantity here, and we write beta, which is the power. Right now we do not know. And gravity, this gravitational acceleration, so this is the acceleration, and we know that the acceleration is, the dimension of the acceleration is length divided by time squared. Time squared. But here is gamma, so we write gamma here. So the left hand side, as we said, must be equal to the right hand side. So since there is no m on the right hand side, so this must be, so the m must be 0. Sorry, the beta must be 0. Since no m on left hand side, which implies that the beta is 0. Similarly, we have the no L. We have the no L on the right side, on the left side, but we have two L's here. So, which means that we have two L's, but one has the power alpha and one has the power gamma. So the alpha, since we do not have L on the left side, so it must be 0. So alpha is for, we take it from this L, and when we have this L, so this must also be 0. What about time? So we have time here, which has the 1 over 2. 1 over 2, it's in the denominator, so it's minus 2 gamma. So, and on the left side, we have 1. So if we take from this time here, so we have 1 on the right side, and on the left side, since it's in the denominator, if we bring it to the numerator, we will have 2 alpha, and that implies that this is gamma. Gamma is equal to minus 1 by 2. If we put the gamma in this equation here, we will get that the alpha is also 1 by 2. So gamma is minus 1 by 2 and the alpha is 1 by 2. If we put the 1 by 2, insert these values in this equation here, so we have the square root here, and then we have the 1 minus 2 here. So in the end, we will get that the time is equal to a constant. Right now, this constant we do not know, but that it depends. So we have the h, for example, alpha was 1 by 2, so alpha is 1 by 2, which is the square root, and now, and since it's minus 2, the gamma, so we have the, or we just write h by g, and it is proportional to h, because this is constant and this is constant, so this is proportional to the square root of square root of the height. So right now, using the knowledge of the dimensions, that the left hand side must be equal to the right hand side, we just found out that how long it will take, so we have now the formula for that.